Hi friends, is my voice is audible? If my voice is audible and if everything is fine, please let me know. Right? Okay. One second. Let me check. Is my voice is audible or not? Uh, yes. One second, brothers. Right. Okay. One second, brothers. Hmm. Yeah. Okay. If you people are in online, please say a hi so that I will understand. Right? Yes. I hope my voice is audible. Vasant Sai, hi sir, hi, hi Vasant Sai. Is my voice is audible, right? Okay, I hope my voice is audible. Today's the session is all about limit state of lecture second part, and in this today's session we will tackle some of the codal provisions and if time permits me, we will work out some of the problems also, right? But tomorrow's session is completely full of problems. Right. So before I start the session, I just want to say a very big hi to all of you. And there are so much of free content is already happening in Unacademy Learning app. So if you are a serious aspirant of GATE or ESE or any other competitive examination, I can recommend to use that free content which is getting delivered in Unacademy Learning app also. And if you want to take a paid course subscription, then I can recommend you to take this paid board subscription by using this code VT10. Right, when you use this code VT10 to take the paid course subscription in an Academy Learning app, directly 10% discount will directly come to you on all the courses, bros. Right. Some people will also ask us, sir, okay, I just want to sir, please introduce yourself, because this is our first class. Some people may say like, so let me introduce myself. I am Venkata Tilak. People call me as Venkata sir, some people call me as Tilak sir. I completed my master's degree from University of Sheffield, England, and about to complete my doctoral degree also. My background of education is completely into structural engineering. So here also in an academy, I am going to teach the structural engineering subjects ranging from engineering mechanics, strength of materials, structural analysis, concrete structures, steel structures, and finally to construction materials and management, right? And some people will also ask us, sir, what is the specialty of this university, from where you people had graduated? This university has produced 6 Nobel Prize winners. You can understand the potentiality of this university, and the ranking of this university always stood less than 100 globally, worldwide. And moreover, this university ranking is far better than IITs and IISc Bangalore. So this is the priority of this university from where I had graduated. And in addition to this one, coming to my previous work experience, previously I worked as research scientist or research engineer in University of South Carolina, which is in USA, for the for a funded project. For that funded project, I even had leaded the team also. And second thing is, previously I worked as civil engineering head of the department in engineering college. This is in Andhra Pradesh. This is in India. That means both I have local experience and global experience also. Even till today, being a structural design engineer, I am working as a structural design consultant. I personally give to my clients structural drawings and material testing reports to my clients, in addition to teaching. Of course, till today I have 12 years of teaching experience. I had mentored so many students, lakhs of students, and I can say like I worked in different coaching institutes all across India, right? Okay, some people will say like, sir, you asked us, you told like so much of free content is already happening in this Unacademy Learning app, na sir. First, how to install that one first? So go to Play Store. I hope you can go to Play Store, and in that, go to after you go to Play Store, type this name Unacademy Learning app. When you type this name Unacademy Learning app, this type of championship type of trophy symbol will come to you. When this type of championship type of trophy a app is coming to you, install that. When you install that, I hope clearly you are able to see on the right hand side a screen. which is showing you in this way. The right hand screen shows when you open that app, you are able to see here. This is the target what you want to achieve. Set your goal. Set your goal as this is the goal what you want to achieve. Set your goal as the competitive examination what you want to crack. Maybe the GATE and ESE, maybe or SSC JE or other PSU examinations, or maybe banking or whatever, maybe what you, it depends on your interest. Now you select your goal, and after you select your goal, I can say like go to free classes first. I mean, there are two things are here. Go to here in this drop down menu. In this drop down menu, go to free classes or courses. After you go to free classes or free courses, then only in the search button you type my name, Venkata Tilak Uppalapati. When you type my name right now after moving to free classes, then definitely my profile will be visible to you. And when my profile is visible to you, I can recommend you like you follow me. When you are able to follow me, what are the advantages? Like the first advantage is already done free content in Unacademy learning app that you are able to access. And second thing is the upcoming video lectures of mine for free of cost you are able to access. And the third thing is at the end of each and every session in app, we will provide a PDF notes. That PDF notes also you are able to access. That is the greatest advantage when you follow me, right? Okay, now everybody will also ask us, sir, okay, sir, this is fine. Okay, now I want to join the paid course, sir. How I can join the paid course? To join the paid course, I hope you can see this drop down menu. Na? In this drop down menu, go to Unacademy Plus, Unacademy or Plus courses. In the plus courses, while you had selected this target as GATE and ESE, in this plus courses, if you had gone, there is a terminology called as get subscription. Get subscription, and if you press on that one, it will ask for payment details, and the payment can be done monthly wise, and also the payment can be done at a time. So get subscription, by the time you press the get subscription, use code BT10. When you use this code BT10, definitely I can say 10% discount will come, and remaining thing is you need to pay the remaining 90% amount from your credit card or debit card or from your internet banking, depending on the mode of comfort that you can do, right? This is how you can do, bros, right? Let me here let me just say use this code VT10 to get 10% discount. When you use this code VT10, directly it will connect between you and me, and that shows your trust on me, right? And directly it will provide 10% discount for all the courses in Unacademy Plus. Definitely from 6th standard to PG standard, for any course, if you apply this VT10 code, definitely you are bound to get 10% discount, right? Some people will also ask us, sir, okay, what I will get if I have taken this paid course or subscription? The advantages of the paid course, the first and foremost advantage is instant doubt resolution is the first and foremost advantage, in addition to daily live classes. So so the educator can directly talk, I can say the learner can directly talk with the educator, and the learner can resolve all his doubts by chatting with the educator, and the educator will resolve all the doubts of the learner with the help of polls. That is the first and foremost advantage. So that second advantage, in order to crack any sort of competitive examination, I can say definitely there is a requirement of test series support is there. That test series support also we are providing if you had taken the paid course. The test series support will be given in terms of mock test, daily wise test, grand test, online quizzes and all this stuff. After writing those tests and quizzes, you can evaluate your performance and after evaluation of your performance in terms of marks, you can compare your performance with the topmost students of an academy. And if you are lagging in some of the areas, in such cases, definitely you can improve your performance by listening to more video lectures in that particular topic, and by working out more problems, and by attempting more quizzes, and by doing more problems in that particular topic. Like that you can improve, definitely improve your performance, right, in terms of marks or in terms of rank. That is the second advantage. Third advantage is there, all the courses that are provided by Unacademy are completely structured courses. There is no need to, there is no need of any plan, plan to be prepared by you. We will provide all the plan. If you follow that plan, definitely we are pretty much sure like you are able to crack any sort of competitive examination with very good rank. And coming to the syllabus that is there in this courses are that the syllabus will be the latest syllabus of GATE and ESE, in a structured manner, so that even the below average student can cope up with our lectures. Like that we will frame the course, right? So that is the third advantage. And coming to the fourth advantage is, let us suppose on some of the days, because of domestic works, some of the students cannot access the live classes. In such cases, for them they will be given the recorded version of the same lectures, maybe through by my mobile phone or maybe through smartphone. For n number of times, he or she can access the same recorded version of the lectures, which is a very useful thing. And if you had taken subscription, you will be provided access to all the courses within that branch, within that specialization of civil engineering. How many courses that were launched by the time, for all the courses the access will be given, right? Sir, okay. Koppala Kaushik, thanks for the motivation. Okay. Right. Sir, what is flexure, sir, in limit state method? Dear, flexure means because of development of bending moment to resist the bending moment in beams. What is the section size that I need to provide? That is what is designed for flexure. That design for flexure in limit state method of practice, we are working out that. Okay, dear Ramdut Shah, is that okay? Right. Okay, right. And these are some of the topmost educators that we have. You can have a direct look at that. And if you want to follow me in an academy directly, you can use this link and you can follow me directly on the app, right? So these are also some of the topmost educators. I just want to convey one more thing. There is no language barrier also. Some courses will be taught in English, some courses will be taught in Hindi. So depending on your comfort, if you are in English medium, if you are good in English, you can listen to the English lectures. If you are good in Hindi, you can if you are good in Hindi, you can watch Hindi lectures. So both will be taught separately. There won't be any language barrier. Okay, right. And I just want to convey, especially Ramdut Shah will ask us, sir, in GATE and ESE, till now, in GATE and ESE, especially in civil engineering, how many courses you people had launched? Totally, we had launched 8 courses, and out of 8 courses, few are in English, few are in Hindi. Few are in long-term batches and few are short-term batches. When you had taken the paid subscription, dear brother, you will be given access to all the courses in that particular branch, right? So to there is no need to go to Bombay, Delhi or Calcutta. Everything is right now available at your doorstep through internet. I can say the topmost faculty of India are right now available to you through Unacademy. Just if you are able to use this code VT10, definitely the doors and windows of Unacademy are directly open to you, and you can get learn from the India's topmost faculty, right? Sir, how many lectures you have taught for RCC? Dear brother Ramdut Shah, I think till now I had covered four hours of lectures in RCC. So it's not at all a problem. I will go slow only here so that every people can understand. It's not at all a big deal, dear Ramdut Shah, and you can watch. Okay? So it's not at all a problem. Right? Right. Hi Kopala Kaushik. Hope you are fine. Right. And I just want to convey some, coming to the financial terms. If it is a 12 months course, I just want to uh, I just want to convey for 12 months course, especially what is the cost. Some people will ask after 10% discount, the cost is 27,225. If it is an 18 months course, the cost is 34,650. If it is a 24 months course, the cost is 39,600. So these are the costs, definite. These are the costs that you can see. I can recommend this 24 months course for the students who are in third year and also in second year, definitely. Right. So for any of the course, if you want to get 10% discount, you are bound to use this code VT10. Definitely 10% discount will directly come. And every day in this channel, Let's Crack GATE and ESE Civil YouTube channel, these three special courses are happening from October. So don't miss this opportunity to get trained from India's top post faculty in this Let's Crack GATE and ESE Civil YouTube channel. Here as a team, we are working here, so you can avail that opportunity. Every day my class in this Let's Crack GATE and ESE Civil YouTube channel is happening by 11 a.m. So don't miss that chance and come down every day by 11 a.m. Right. And I already started a Telegram group also. The name of that Telegram channel name is Unacademy underscore civil engineer Tilak. And if you want to join the Telegram channel, use this link which is just below. If you press down that link, definitely it will redirect to my personal channel. Right, in that personal channel, whatever may be the doubts that you have, you can you can ask those doubts. Yes sir, price increased, sir. Yes, Ramdut Shah. From October 20th, the price has got surged. Right, it has got increased. Right. Right. So I want to convey you, as you are getting all this for free of cost, na? And if you don't want to miss even a single video, then I can recommend you to subscribe to our channel, to this channel, and don't forget to press the bell icon. Right? Please raise a thumbs up to our lecture so that we can do more videos for you. Right. So let us start the session, bros. Ramdut Shah and Kopala Kaushik, Vasant Sai, or any other persons who are on the online. So in your previous class, especially, we started a limit state of flexure. Right, in that limit state of flexure, we had seen in your IES, as per IS 456 2000, this is how the strain block is there. This is how the stress block is there. Right, this I had mentioned the reasons why the maximum strain in concrete is this much. This I covered in your previous class. Why the strain in steel, why the strain in concrete at the time of yielding is 0.002, with reason I mentioned in your previous class. Why the distribution of this stress in concrete under compression is just like that of this one, is just like that of one part is just like that of rectangle, another part is just like that of a parabola. I already show how you got this curve, and also in your previous class. Right, isn't it or not? And one more thing, this is the strain in steel. What is the strain in steel that we got at the time of failure? The strain in steel at the time of failure, in your previous class we had already derived that one. If you memorize or not, we had already found like epsilon st, strain in tension steel, and we got that epsilon st should be greater than or equal to 0.002. This I had already derived. I just want to convey this. I had derived in your previous class also, in 0.87 times of Fy by Es. This is what I had done in previous class. Now, especially our brother Ramdut Shah, it's not at all a problem. Just after this class, you can go back and you can do. The lectures are there in YouTube, na? It's not at all a problem, Ramdut Shah, bro. Okay? Don't worry, brother. I am there with you. Don't worry. That lecture is there in YouTube. Just after this live class, you can go through that one. It's not at all a problem. Okay, right. The question is, sir, in the generally so sir, for the design of flexure, here design of flexure for beam means, sir, what is the section size of the beam I need to provide? How much is the area of the tension steel I need to provide? To do all these things, generally I need to find out the depth of neutral axis. To find out the depth of neutral axis, I need to find out what is compression force, what is tension force, right? Isn't it or not? So to find out compression force and all this stuff, I need to teach you how I can evaluate the depth of the stress block, the depth of this parabolic. Let me show you. I hope you are able to say. I need to teach you how to find out the depth of this parabolic stress block, right? What is the depth of this rectangular stress block? I need to teach you. If the total depth of neutral axis is xu, if let us suppose xu is depth of neutral axis, right? If xu is depth of neutral axis, and you know the strain distribution is in this way, so this point not 2 is the strain in concrete at the time of yielding, right? So how you can work out x1, how you can work out in terms of xu, right? X2, how you can work out x2 in terms of xu. I hope you know clearly what is x1 here and what is x2 here, right? So what do you mean by x1 here? X1 is the depth of parabolic depth of stress block. X2 stands for rectangular depth, rectangular variation of stress block here, depth of rectangular stress block, right? So x1 plus x2 is xu. So I hope you know from this directly. I hope clearly, I hope you are able to see here, right? From this triangle, right? From this similar triangle properties, I hope you people are good in similar triangle properties. Here if it is theta, this is also theta na. So from similar triangles properties, if I write tan theta for this, may be this may be triangle A, this may be this way. From triangle A, if you write, how you can write tan theta opposite side, this is 0.0035 by this distance is how much, brother? Xu. Opposite side by adjacent side is equal to, again this opposite side is how much, brother? 0.002. What is this distance, brother? This distance is x1, right? So from similar triangles properties, yes, in working stress method, this process will change. In working stress method, dear brother, the stress block is just like that of a straight line variation, and the parameters of this permissible stresses, I can say the design stresses will definitely get changed, brother. Yes, the variation of this stress block will definitely get changed. It will not be in the fashion of rectangular stress block and parabolic variation. It will be just like in the format of just like that of a straight line. Yes, brother. In working stress method, it will get changed. I mean, the stress block will get changed definitely. Their factor of safeties are also different, right? So but I am talking about in terms of limit state method. Okay, right? So now, in when I do this one, generally I just want to convey from 2000 onwards, we are using only this limit state method. We can only apply this working stress method, whatever you are talking, only for water tanks or the structural elements which are inside the water, right? So for that structural elements only we can use working stress method, but for remaining all the structural elements we must and should use only limit state of method only, right? So okay, let me talk about this limit state method. Okay, anyway you asked us, I just answered you. Now from this one, what is this depth x1? So how you can write this x1 is nothing but depth of parabolic stress block. How much you will get from this one xu? I am getting that x1 as 4 by 7 times of xu, which is 0.57 times of xu. What do you mean by x2? X2 stands for, I hope clearly you are able to see what is this. X2 stands for depth of depth of rectangular stress block, depth of rectangular stress block, right? So how you can get that one, brother? So I hope you can get this x2 directly from x2 is equal to xu minus x1. So from that one directly you are bound to get the value of x2 is definitely 3 by 7 times of xu. Okay. Ramdut Shah, sir. Can you define factor of safety? What it is? I am not able to understand. Okay. Dear Ramtucha, just please tell me in which standard you people are. I mean, of course, I will define that one. Okay, factor of safety. So, how you can say about factor of safety? Factor of safety, or another name for this one is partial safety factor of material, right? So how we can mention this one as factor of safety or partial safety factor of the material is actual failure strength of the material to divided by a design strength of material. Generally, for the safety purpose, generally, if the strength of the material is 100 kilonewton, in design we will generally think like the strength of the material is not 100, we will consider it as less than 100, like maybe 100 by 1.5, or maybe something it is less than 100, we will consider. Generally, if I consider less than 100, I will keep the size of the section more. When I keep the section size more, definitely it will be under safe condition, right? If I keep lesser section size, then definitely more stresses development are possible. But if I keep somewhat higher section size, lesser stress will be developed. So the concept is very simple. So whatever may be the strength parameter in design, I need to underestimate the strength of the material. Whereas the load coming on the structure, I need to overestimate. That will leads to safer design. That will leads to I can say safer designs easily. If you do the design uh, with exaggerated load, and if the strength of the material is underestimated, then I will try to then I will provide higher section size. In such cases, the stress development in the structure will be less, right? Is that okay? Yeah, Ramducha, right? So yes. Okay, I hope you understood this one, X1 and X2. Now the question is, sir, I need to work out the compression force and I need to work out the tension force. So first of all, I just want to work out the tension force. So how you can work out the tension force here, brother? So can you work out, maybe I just want to work out tension force developed where the tension force is taken care by tension steel. Concrete is weak in tension, so this the concrete under tension, this is compression zone, this is tension zone. In tension zone, only the tension steel is effective in resisting the tensile stresses. What is the tension force developed in tension? What is the tension force developed in tension steel? What is the answer? The answer is design tensile stress of steel multiplied by cross sectional area of steel in tension zone. What is the design tensile stress of steel? So I hope if you can say design tensile stress of steel. I mean, which steel, man? Reinforcing steel. I can write multiplied by, I can write this one and I can multiply this one by area of steel in tension zone, AST. This is how I can write. What is the design tensile stress of reinforcing steel, brother? The design tensile stress of reinforcing steel in your previous class. What is the design tensile stress? It is the actual failure strength of the material divided by factor of safety. Actual failure strength of the material of reinforcing steel is Fy, divided by factor of safety for steel as per limit state method is 1.15. So Fy by 1.15 into AST. If you do this one, definitely it is 0.87 Fy into AST. This is the tension force in tension steel. This is how you can work out 0.87 Fy. This in your previous class, I had derived this one. In your previous class, I had derived this. How I got the design tensile stress of reinforcing steel as the actual failure strength of the material divided by factor of safety or partial safety factor of that reinforcing steel, which is 1.15 as per limit state method, as per limit state of collapse, right? Yes. Now everybody will say, sir, you worked out this tension force, sir. Okay, our major interest is to find out the actual depth of neutral axis. right? In terms of AST and all the stuff. Okay, so you worked out tension force. When you work out this compression force, if you write compression force is equal to tension force, then definitely we are able to work out the depth of neutral axis. Yes, it is 100% correct. To work out the depth of neutral axis XU in terms of AST and all this stuff, definitely I need to work out the compression force. How you can work out the compression force, brother? Do you have any idea how to work out the compression force here? This is the compression zone. First area and the second area, this is the compression zone, isn't it or not? Now I just want to work out the compression forces. Is that okay? I just want to show the same figure in a larger scale, right? So this is how. I hope you are able to see. This is the stress block, right? This is the stress block in compression zone. I just want to exaggerate this, exaggerate this one in a bigger size, right? And this is how the stress block that is acting. If you see, this is how, maybe I can say, this depth from this top to this depth, this is nothing but depth of neutral axis. We people call it as maybe XU, definitely, right? So as per your previous figure, this figure is maybe first area, this figure is second area. Is that okay? This figure is first area, this figure is second area. So how you can say what is this first area? So the compression force acting on this first area is C1, right? Compression force acting on this second area is C2. I need to work out that one. What is this total compression force C? Total compression force C is equal to C1 plus C2. I can work out. How you can work out this C1? C1 is equal to, how you can work out the compression force on the first area, first block. I can say compression force acting on this first area is equal to average stress which is acting on this first area. You tell me what is the, this is stress block na, so this stress is how much? This is 0.45 FCK. We had already derived in our previous class, 0.45 FCK. Okay, right? Now you tell me on this first area here clearly, what is the average stress? On the top layer of the first area, the stress is 0.45 FCK. On the bottom layer of the first area also, the stress level is 0.45 FCK. On the middle layer also 0.45 FCK. So the stress distribution is a constant on this first area, right? So the average stress acting on first area into A1. What is that average stress acting on that first area, brother? The average stress acting on that first area is 0.45 FCK. What is that area A1, brother? This width is B, right? This width is already x2, right? I hope clearly you are able to see clearly, like this depth is definitely x2, isn't it or not? Isn't it? So this is B into x2 is the area of the first block. So area of the first block multiplied by average stress acting on the first block, which is 0.45 FCK multiplied by B times of x2. This is how I can work out compression force 1. Now my brother Ramdut Shah will come and ask us, sir, okay, this is fine. Now you tell me what is the compression force that is what is the compression force that is acting on this second block, right? It is also one and same, like what is the average stress acting on that second area multiplied by area of the second block, right? So what is the average stress acting on second block? I hope you can see for this second block area, on the top layer of the second block you are able to see this much, like 0.45 FCK is the stress that is acting on the top layer. On the bottom layer it is 0. And if you see the variation of that stress, what is the variation of this stress from this top layer of the second part to bottom layer of the second part? And the variation is just like that of a parabola. When it is just like that of a parabola, what is the average stress here? Maybe I can say, maybe somewhere here there, maybe this is the average stress. What will be this average stress when the variation is just like that of parabola? So this value is obviously or already 0.45 FCK, right? So this may be the average stress here. I can say average stress. How you can work out this average stress? Here, average stress is equal to, as this variation is just like that of parabola, I can say two-thirds of this top value and this bottom is 0. The top value is 0.45 FCK plus 0, right? Yes. Clear answer understood. Okay, okay, okay. This is how, because this variation is this much. When it is a straight line variation, now brother, then we can write like, sir, when it is a straight line variation from here to here, we can write it as, sir, it is 0.45 of ck plus 0 by 2 when it is a straight line variation. But here the variation is just like a parabola, and this type of parabola, that's the reason why we are going for two-thirds. Two-thirds of this top and bottom, we can write. So in such case, we can write two-thirds of this is the average stress on second block is two-thirds of 0.45 FCK plus 0 into what is the area of the second block, brother? The area of the second block, I hope this width is clearly, I can say, maybe let me change the another color better. Yes, this width is already B, and this depth is how much, brother? The depth of the second block is, I hope clearly you know, this is x1. X1 is the depth of the second block, so I can write B into x1. Is that okay? So what is the total compression force, brother? The total compression force we can easily work out by adding compression force acting on first area, which is C1 here, the compression force acting on second area, which is C2. If you add up C1 plus C2, definitely you are bound to get this total compression force, which is C. The total compression force C is C1 plus C2. So try to work out C1 plus C2. You are bound. I hope you can do simplification. If you do this simplification, and some people will say, sir, here it is x2 and here it is x1, but here the answer is in terms of xu. But I hope you already know, you already worked out x1 value is already 0.57 times of xu, which we people call it as 4 by 7 times of xu, x1 value from the bottom, whereas x2 value is 3 by 7 times of xu. This is already derived. I can say, maybe you can substitute this one. I can clearly write already derived in previous slide. I hope we had already derived from similar triangles properties. If you see this one here, clearly we had worked out from similar triangles properties. Clearly it was worked out, na brother. So there is no need to worry. All this is known to you. I just want to convey, right? So try to substitute x1 here, x2 here in terms of xu. When you substitute x1 and x2 in these equations, finally you will end up, because if I showed everything in this slide, na, it will be like 2 to 3 pages only. That simplification will take. I hope you can understand. This is the way how you can work out very easily. Is that okay, dear Ramdut Shah, Koppala Kaushik, and any other person who are on the online? So can I move to the next slide? Now everybody will say like, sir, I got the total compression force, sir. It is fine. I got the total compression force. Okay. Now the question is compression. It is a force. Force is a vector quantity. For a vector quantity, in addition to the magnitude, I need to show the direction, and I need to mention the point of application, or point at which this has got applied. This point distance, the distance at which it is getting applied, that point of location should also be mentioned. So I need to find out that point of location of that total compression force C, isn't it or not? Will you accept that? So because that is a vector quantity, I need to mention at what point that total compression force is also acting. That point of application, at point of location where that total resultant compression force is acting, I should mention that one, because it is a vector quantity. Isn't it or not, brother? Right? So I am right now interested to find out that distance of this total compression force C. I just want to work out the distance of this total compression force C from this top layer. I hope you can see this is the top layer. From the top layer, what is the distance of this total compression force C? It is y bar. I am interested to find out this y bar, bro. Is that okay? Right? So can I show that one? Can I rub the screen here? Can I rub the screen here just? Can I rub the screen here? Right. I had just rubbed the screen. I hope to work out this y bar. Y bar is the what I just want to write what is y bar here also. Okay. Some people will say, sir, what is y bar? Y bar is the centroid distance of resultant compression force C. Resultant compression force C from extreme compression fiber. Right? Yes, from extreme compression fiber. Dear Ramdut bro, it is correct, no doubt. Everybody, if they refer IS 456, they are able to write all these answers very well. It's not at all a problem. But if you refer to the gate problems, in gate problems they are changing the partial safety factors of the materials, they are changing the variations of the stress block. So because of that such cases, for that given stress block variation, we need to find out our own compression force, we need to find out our own tension force, we need to find out our own we need to find out the actual centroid distance of the compression force from the top fiber, and we need to develop our we need to develop the moment of resistance formula also for the given stress block parameters and strain block parameters. That's the reason why I'm trying to derive this one. Else for competitive examination this derivation is not required. But why I'm teaching that one? Because the models of questions in gate are giving in such a way that one, if you understand this derivation for the new stress block, how they had given for that stress block, for that variations, you can derive your own stress block, you can derive your own equations, and you are able to solve that problem. If you don't understand this derivation, I am pretty much sure like you will not attempt the gate examination in this part of limit state of flexure. Okay, yes, everybody knows, like everybody will tell me like, sir, it is very simple, this is 0.4 to XU, because everybody do so many number of designs, it's very simple. Yes, as per IS4 it is correct, but for gate examination, this stress block variation, this is how it is, this is the 0.45 FCK. How you got this one? FCK by the shape and size factor is 1.5, divided by factor of safety is again 1.5. So because of this one, you are going to get 0.45 FCK. But if it is not 0.45 FCK, if the factor of safety here it is 1.5, the factor of safety is 1.25, this value instead of 0.45, it will definitely get changed. It will definitely get changed right by the time you are not free to use IS 456 codal formulas directly. In such case, you need to derive your own. Okay, so that's the reason why I am teaching all this. Else it is not required. Okay, but right, yeah. Okay, now the question is, okay, sir, how to find out this y1 y bar, sir? So can you derive this one, brother Ramdusha? It's okay. That the answer is very perfect, no doubt. I just want the derivation expectation from you so that you are able to derive the same type of stuff even for when this stress block values, stress block depths has also got changed. Then I hope you can work out this y bar also. I am just expecting this derivation y bar. I do you know, dear Ramdut Shah, do you know how you can work out this y bar? I hope you know the concept of Varignon's theorem. How you can work out the what is this Varignon's theorem teaches you? The Varignon's theorem teaches you the moment of a resultant force about a point. The resultant force is this compression force C. The moment of this resultant force about a layer or about a point, about a level, which is C into y bar, is equal to sum of the moments of the individual forces which are causing that resultant. What are the individual forces which is causing this resultant force C? The individual forces are C1 and C2. So summation of moments of these individual forces about the same level. So I can write which is equal to C1 into what is the perpendicular distance of this C1 force from the top. I can say Y1, C1 into Y1 plus summation means plus, and C2 into the centroid distance of the C2 from the top layer is Y2. C2 into Y2. So from this one only, I am able to write this Y bar as C1 Y1 plus C2 Y2 by total compression force C. Okay, now everybody will say like, sir, I know C1. Everybody will easily say like, sir, I know C1. There is no problem at all. I know C2 also. That is, there is also no problem, because you can see this is C1, this is C2. Okay, this total C also I know, sir. But if I am able to work out Y1 and Y2, which is justly, sir, will you work out some questions also? Definitely, dear Shebin Sailuddin, definitely I will work out, because I had given 10 hours for limit state of flexure. I think 12 hours I had given for limit state of flexure, brother. Dear Shebin Sailuddin, I had given 12 hours for limit state of flexure. Do you know? 12 hours I had given for limit state of flexure. Don't worry, every problem in limit state of flexure, every model I will work out. Okay, but it may take some time, because you need to be strong in fundamentals. Just after the fundamentals were taught, definitely I will work out all the problems. It's not at all, I will not leave even a single problem also, right? I may teach 30 to 40 percentage, but 30 to 40 percentage of the syllabus I will complete in detail. Okay, so that even in any competitive examination, even in any ESE examination also, you are able to crack. That will happen. It's not at all a problem, bro. Definitely, I'm pretty much sure you will crack that one. Okay, right. Now the question is, sir, how you can work out this y bar, right? Can you work out, how can you work out what is this y1, bro? So how you can work out this y1? It is x2 by 2, right? So y1, it is equal to x2 by 2, right? So how you can work out this y2? Y2 is equal to x2 plus the centroid distance. What is the, so can you write y2 is equal to, how you can write y2? It is x2. This is from here to here x2. From here to here it is the centroid distance of this one is definitely, if this is total distance is x1, from this one definitely, I hope you know the centroid distances. Centroid distance of a parabola, if it is in this way, if this distance is x1, in this, from this one, this distance is definitely 3 by 8 times of x1 is this distance. So in the same way, this is 3 by 8 times of x1. So y2, how you can write x2 plus 3 by 8 times of x1. So if you are able to write x1 and x2, and I hope you know what is the answer of x1 and x2. So maybe I hope you know x1 is equal to 4 by 7 times of xu. X2 is equal to 3 by 7 times of xu. Just try to substitute all these things in this above equation. So definitely, brother, in such case, after you work out this stuff, definitely you are bound to get this y bar as, definitely this y bar is 0.42 times of xu. This is how you will get. Is that okay? Dear Shaybin Sahiluddin, is that okay? Right. Now the question is, sir, okay, sir, you worked out this y bar also. Maybe I can say from this top, this is y bar. Everybody will cry. This is y bar. Okay. Now you tell me, if the lever arm is L, if the lever arm is L, what is the centroid distance between compression force and tension force? The centroid distance between compression force and tension force is, already this is effective depth. I hope you know. This is effective depth. Effective depth minus y bar. Effective depth minus y bar is this lever arm, I can say. Now everybody will ask us, sir, why you require labrum and all this nonsense? Why you require all this stuff? I just want to say, some people are expecting moment of resistance. So how I can work out the moment of resistance of the cross section? The moment of, how you can define moment of resistance of the cross section? Resistance of cross section for externally applied moments due to loads. So resistance of the cross section for externally applied moments due to loads. That moment of resistance we can directly write as generally compression force into lever arm, or which is equal to tension force into lever arm, right? In this way you can work out, brother. Now everybody will know how to work out how what is this compression force. Everybody will knows this. How to work out the tension force. Tension force is 0.87 Fy maybe AST, right? So compression force 0.36 FCK B into X. This is the compression force as per the IS 456 stress block. Maybe in your gate examination with the stress block and the parameters factor of safeties or partial safety factors has got changed. This compression force and all this stuff values equations will get changed. Please understand that. Okay, for our IS 800, for our IS 456 stress block of 2000 version, these are the equations. Okay, now this lever also, you know, the lever is, this is the singly reinforced section. Now for this one, the lever is D minus Y bar. Isn't it or not? D minus Y bar. Isn't it or not? Now the question is, sir, how you can work out the moment of resistance with respect to compression force? Can I write 0.36 FCK B into XU and lever arm D minus 0.42 XU? I can write in this way. Similarly, moment of resistance with respect to this is with respect to compression force, right? Some people will say, will ask us, sir, can you write the moment of resistance of the cross section of singly reinforced section with respect to tension force? Yes, with respect to tension force. What is the tension force? I can write is 0.87 Fy AST. 0.87 Fy AST. This is tension force into lever arm. That lever arm is D minus 0.42 XU. This is how you can work out. Okay, isn't it or not? Right, this is how you can work out. Maybe this, maybe we can call it as maybe equation one way. This maybe we can call this as equation two. But anyway, the moment of resistance will be one and same. I can say under till failure, till limit state of flexure, till failure, at any cost, till failure, I can say under all circumstances, till failure, compression force is equal to tension force. That means either compression force into lever arm I can write, or either I can write tension force into lever arm also I can write, right? I can write either compression force into lever arm or I can write tension force into lever arm. Anything is one and same. It will work well. Okay, right. Now people will also ask us, sir, okay, sir. So now sir, to write the moment of resistance here, there are different types of sections are there. Some people will come and say like, sir, how we can work out the neutral axis, sir, how we can work out that one. So I just want to show you how we can work out the neutral axis also. Is it okay, right? I just want to show you how to work out actual depth of neutral axis, how to work out the critical depth of neutral axis also. So I hope you this left hand, this right hand side is over. Okay. Now in neutral axis, there are I can say two different types of neutral axis. One is balanced depth of neutral axis, or I can say limiting depth of neutral axis, or critical depth of neutral axis, or maximum neutral axis, or XU max I can write. Second neutral axis is called as actual depth of neutral axis. I just want to talk first about this balanced or limiting or critical or maximum depth of neutral axis. I just want to talk about this first one. So in what is this type of neutral axis? This is the neutral axis for balanced failure. What do you mean by balanced neutral axis? Balanced neutral axis is the neutral axis for balanced failure. What is balanced failure? Balanced failure is a failure at which both steel and concrete both will fail at a time. Steel in tension zone and concrete in compression zone will fail at the same time. How these two could fail at a same time, brother? So for that one I can say like I can say when both steel and concrete reaches their permissible stresses and strains at the same time, then both steel and concrete in tension steel and concrete in compression zone will fail at same time, right? I hope you know what are the permissible stresses for concrete. For concrete, what is the permissible stress? For concrete, the permissible stress is 0.45 fck. If in concrete, if in concrete the stress reaches by 0.45 fck, and for steel, yes, I will tell you. Ramdut, 1 second, 1 second. For steel, what the permissible stress is 0.87 F5. So when in steel, when these metals will reach these values at the same time, then we can say the failure will also happen in these two metals at the same time. Now, as per the question of permissible stress, as per our Ramdut Shah is asking like a question, like, sir, what is permissible stress? I already mentioned in your previous class. For that one, maybe I just want to erase. Can I erase this one just before I want to talk about permissible stress, the definition? Yes, I just want to erase this one. Okay, what is permissible stress? Another permissible stress. Another name for this permissible stress is also called as design stress. Another name for this one is also called as limiting stress. Okay, another name for this permissible stress is also called as allowable stress in material. These are different synonyms in material, right? Right. Sir, his neutral axis is the axis where concrete fail in brittle and steel fail is yielding. There, how you can define neutral axis? Neutral axis is a layer at which both stress in that layer is zero and strain in that layer is zero. It is a neutral layer which will not be stressed at all, which will not be strained at all. It will not be subjected to any sort of stresses, and it will not be subjected to any sort of strains. So your definition is wrong. So the actual definition is neutral axis is an axis at which both stresses and strains in at the level of that layer of the material is zero. There won't be any stress at all. Clearly, I hope you are able to see here. Maybe 1 second, let me show you. I hope clearly at this, if this is neutral axis, I can say this is the neutral axis. At this level, the strain is zero. At this level, stress is also zero. I hope clearly you are able to see. So it won't be stressed at all. That is the fundamentals of your strength of materials. Your SM teacher might have already teach you that. That is the fundamental of strength of materials, dear Shapin Seheluddin. Okay, anyway, it's not at all a problem. You are free to ask even the very fundamentals also. I am here to teach you, but I just want to relate where that concept has came from. That neutral axis concept has came from. I hope you might had learned the strength of metals in that one limits. In that one, there is a terminology called as flexure. I can say beams. In beams, you might had studied that. Okay, right. So, oh, sorry. Right. So some people will can work out this balanced neutral axis depth. I hope is that okay, dear Ramdut Shah. What do you mean by permissible stress of a material? Permissible stress of a material is nothing but design stress of the material. How you can work out this design stress of the material, which is characteristic strength or actual failure strength, a characteristic strength of material divided by factor of safety of material. What do some people will also ask me, sir, what is characteristic strength of the material? Maybe in layman language I can write the characteristic strength of the material as the actual failure strength of material in laboratory divided by factor of safety of material. This is how you can say this: permissible stress, design stress, okay, limiting stress, allowable stress, okay. All these are all synonyms. All are having one and same meaning. Is that okay, dear Shebin? Is that okay, dear Ramducha, brother? Is that okay? Can I move to the next slide talking about how to find out that balanced depth of neutral axis? So some people will also ask us, yes, sir, for every design works, we consider factor of safety. Yes, even in maybe in working stress method, or maybe in ultimate load method, or maybe in limit state method, even for any material, every time we will consider factor of safety. But depending on the design philosophy, that factor of safety for the material in the mode of failure, that value may change, but every time we will consider the factor of safety of the material. Maybe the same factor of safety of the material in limit state method, it was called as factor of safety, is also called as partial safety factor of mid. This is the terminology that is used in limit state method. Factor of safety terminology is the terminology used in working stress method, but in limit state method, the terminology for factor of safety is partial safety factor for material. Right. Right. Ramdut Shah, sir, give problem for this. Dear Ramdut Shah, before I give a problem, definitely I will give a problem. But before I give a problem, I need to give some more theories there, right? So yes, definitely. So maybe you are asking, yes, sir, give problem for this. Definitely, I will give problem, dear brother. Please wait, dear Ramdusha brother. There is some more theory is also there in this balanced section, right? Because I teach you about this neutral axis, which is in this neutral axis. Some people will say that this is balanced neutral axis. Okay, in this balanced neutral axis, if you see, so how to work out that balanced neutral axis or limiting depth of neutral axis or critical or maximum neutral axis? How to work out that maximum depth of neutral axis, and how we can do that one? So what is this balanced neutral axis or limiting neutral axis or critical neutral axis is called? This is the neutral axis for balanced failure where both will stay. So I mean to say both concrete, this is concrete, and steel, both these two will fail at the same time. What is the strain in concrete at the time of failure? The strain in concrete at the time of failure is 0.0035. What is the strain in steel at the time of failure? The strain in steel at the time of failure is this much. This I had already worked out in your previous class, right? So if this is theta, by that time, what is the depth of neutral axis that we have? That neutral axis depth is nothing but balanced depth of neutral axis, which we people call it as xu max. From this stress block, from this strain, this is what is the block is nothing but from this strain block, we are able to work out the limiting depth of neutral axis, brother, right? So can you work out the limiting depth of neutral axis from the concept of similar triangles properties? From the concept of similar triangle properties, what you can write like tan theta, it is tan theta opposite side, this is 0.05 by xu is equal to, what is this value? This is already effective depth. It is already effective depth minus xu max. Can I write that one? D minus xu max. Can I write that one? So which is epsilon st. Epsilon st is this much. If you just use this one as 0.002 plus 0.87 fy by Young's modulus of steel divided by d minus xu max. If you equate these two, this and this, from this one, the I hope you know from this equation, you know pretty well about this value of fy is known to you, right? Young's modulus of steel. What is Young's modulus of steel? 2 into 10 to the power of 5 Newton per millimeter square. This is also known to you, right? And D, the value of the XU max by D, the D value will be known to you. Maybe in this, the one and only unknowns are XU max. So if you solve this equation, Okay, definitely we are pretty much sure like the value of xu max is only dependent on. So from this equation, what is the observation that you can write? The value of xu max is only dependent on Fy. It is not dependent on FCK, right? So I just want to write that one. Therefore, xu max is only dependent on grade of steel, but independent of independent of grade of concrete. So every single thing that I am teaching here, every single thing, every even theory also, these theories also, it was asked so many number of times. If you write this xu max is only is only independent of grade of steel, but xu max is only dependent on grade of steel but independent of grade of concrete. This is a note that I want to give you, right? So some people will also ask us, sir, for different grades of Fy, different values of xu max by d values will come na? Yes, definitely, brother. Using this equation, if you substitute the value of Fy for different grades, and if you substitute the value of Young's modulus of steel for all the grades, Young's modulus of steel is one and same na? So if you substitute this one, brother, this is what you will get. So I can say for Fe 255 xu max by d, you will get this one. For Fe 415 xu max by d value, you will get in this way. For Fe 500 xu max by d, answer is 0.46 here, 0.48 here, 0.53 here, right? So this is how you can work out the limiting depth of neutral axis. The limiting depth of neutral axis is a function of only the grade of steel. It is independent of grade of concrete. Why it is independent of grade of concrete? As for all grades of concrete, maximum strain is one and same, which is 0.0035. So irrespective of any grade of concrete, the maximum strain in concrete is always, traditional concrete is always 0.0035. Either it may be M20 or M200. If it is a traditional concrete, generally the maximum strain is 0.0035 only. It is not going to change at all, right? Yes. Now the question is, some people will say like, sir, we know how to work out this maximum depth of neutral axis. Now can you tell me how to work out the actual depth of neutral axis also? So I just want to tackle about how to work out this actual depth of neutral axis. So the actual depth of neutral axis, how to work out this actual depth of neutral axis? We can work out the actual depth of neutral axis by always. So I just want to write a note here. Always actual depth of neutral axis can be worked out by equating. If you at a section, it is in equilibrium. When at a particular section, if it is in equilibrium, even sigma fx is equal to 0 is also valid. When sigma fx is equal to 0 is valid on a cross section, if you take, if this is the compression force, if this is the tension force, these are the forces acting in x direction. So for from the condition of static equilibrium, we can write minus c plus t is equal to 0. In such case, compression force is equal to tension force. From this equation only, we can by equating compression force is equal to tension force. What is this compression force? 0.36 fck beat xu. Tension force is 0.87 FIAST. So if you know the area of steel, tension steel given in tension zone is known, then I can work out the actual depth of neutral axis, right? So this is how I can work out actual depth of neutral axis. Is that okay? Right. Now I just need to complete only types of sections. After I teach you the types of sections, the theory part is over. Now I can start problems. Is that okay? Let me just complete these types of sections, brothers. Okay? Right? So in types of sections, there are three types of sections are there. One is balanced section. Second one is under reinforced section. Third, third one is over reinforced section. There are these three. Okay, these three are there. I want to tackle about these three. First of all, let me tackle about this first type of section in RCC. For a flexural section, the types of flexural section in RCC. Right? First one I want to tackle is balance section. How you can define this balance section? This is used in the design of this can be this type of section can be used in the design of this member. In this balanced section or balanced failure, we can say balanced failure. In this balanced failure, both the compression concrete and tension steel will fail at the same time. How this compression concrete and tension fail at the same time? Because in this section both compression force, compression and tension force, both the concrete, both I can say both compression force and tension force reach to maximum values, and will fail at the same time. This is theoretically possible but practically impossible. So practically this type of failure is impossible generally. So I can say in these cases, as compression concrete and tension steel are failing at the same time, in this case whatever may be the depth of neutral axis that is coming, the depth of neutral axis is definitely it is equal to maximum depth of neutral axis, which is nothing but xu max. So in this particular case definitely we can write the critical depth of neutral axis or actual depth of neutral axis is definitely equal to xu, right? So some people will also ask us, sir, okay, for this type of section of balanced section, as xu max is equal to xu, in this case for this type of balanced section, can you tell me how to work out the moment of resistance? Yes, brother, I can say, tell you about the moment of resistance. The moment of resistance right now for balanced section, moment of resistance for balanced section is called limiting moment of resistance. Limiting moment of resistance. How we can work out that limiting moment of resistance? It is very simple. Mu limit we can write as, maybe some people will say, sir, what is this equation and what is this equation 2? Equation 1 means compression every time. Either limiting compression force, which is 0.36 FCK B into here XU is equal to XU max. Na? And you know XU max also. What is the answers for XU max? For XU max answer, it is 0.53 times of D for FE 250 grade. XU max is 0.48 times of D for FE 415, and XU max is equal to 0.46 times of D for FE 500. This I had already worked out. Already worked out, right? So here instead of XU, generally the compression force is 0.36 FCK B into XU. But as here in this particular balance section, XU is equal to XU max. Na, I can write here as XU max. 0.36 FCK B into XU max. I can write definitely into D minus lever D minus 0.42 times of XU is equal to XU max. Na, I can write in this way. This is how I can write mu limit, or in other words I can write the same as 0. The second, I mean mu limit is equation 1 or 2 with xu max. Now equation 2 is tension force into lever arm. How I can write tension force? 0.87 Fy ast. This is equation 2 multiplied by lever arm is d minus 0.42. Instead of xu I can use xu max. This is how I can work out. Is that okay? I can work out mu limit in this way, right? I can definitely work out mu limit in this way. Now the second type of section. Now coming to the second type of section is under reinforced section. So in this under reinforced section, the name itself says like under reinforced. The reinforcement in under reinforced section, the word itself says under reinforced. That means the reinforcement that we are providing is less than the required reinforcement for balanced section. Reinforcement that we provide, the reinforcement that we provide is less than the reinforcement that is provided is less than the reinforcement required for balanced failure. For balanced in balanced failure, I hope you can understand both compression concrete and tension steel will reach their permissible stresses and strains at the same time. At the same time, right? Isn't it or not? But here, if I require, let us suppose here in this section, if I require suppose some 1000 mm square steel area, but I will provide some steel area some bit less than that 1000 mm square, like maybe 900 mm square or 950 mm square. That much area of tension steel, generally I will reduce the steel area required and I will provide that one. Here I can say that's the reason why I can clearly say, like, here the reinforcement is less than that is there in balance section. So it here the reinforcement is less than that in balance section. In this section here I can say steel provided is less, that is steel quantity is less, concrete quantity is high here. So here as steel quantity is less, our steel number is less, as the steel quantity is less, definitely which one will fail first? Definitely here steel will fail first. So here as the steel quantity is less than the required quantity for a balanced failure, as steel quantity is less, steel will first, I mean reinforcing steel will reach first its permissible stresses. Steel first reaches its maximum value. At that point, concrete is having less than the maximum values of stresses and strains. So as the steel is failing, if a failure is done in steel in an RCC, if steel is failing, that is a good type of failure, brother, because for steel strength is high and also ductility is also high. That means that higher strength is used and I can say higher ductility is also used. Failure of reinforcing steel is always a far good thing. If it is a failure, let the failure should happen in reinforcing steel, not in concrete, because concrete is a brittle material. It will fail suddenly. Whenever a failure is sudden, we cannot stop loss. We cannot stop loss of lives. Okay, so if I want to stop loss of lives in loss of lives because of the failure of the structure, I should make the failure somewhat more ductile. So to achieve more ductile failure in a structural element, the failure should only happen is in steel material, because steel is a ductile material. It has got higher strength and it has got higher ductility also, right? Sir, okay. Sir, what is the meaning of first steel reaches the maximum value? Maximum value in the sense steel first reaches. Okay, let me write. Steel first reaches permissible stresses or maximum stresses and permissible strains. So the steel will reach its allowable stresses. The steel will reach its design stresses. When the steel is reaching its design stresses, the steel is a failure thing. Here, what is failing here? Steel is failing, but in concrete, the stresses developed in concrete and the strains developed in concrete are less than the permissible stresses and strains of concrete. So in such case, concrete is safe, but steel is failing. That is a good thing. So when steel is failing, I can say there will be lot of indications before failure. Lot of indications before failure is more warning signs before failure. Let us suppose if a structure is failing, then the structure before failing is providing more warning, like it is sagging. It is keep on deforming, and it is keep on deforming by the time, and it is giving more and more signs before failure. In the meantime, the residents who are residing inside the structure can come outside the structure, right? So they will be safe, as the failure is not sudden, as the failure is providing more warning. In the meantime, all the residents inside the structure can come out, their lives will be saved, isn't it or not? That is a very good thing in addition to strength. Yes, in addition to strength, ductility, that warning nature is also very much required, brother. So if more and more warning is provided here, ultimately, finally, concrete fails. Finally, after the failure of steel, finally concrete fails in gradual manner. with the support of steel. This is the beauty. Because of this beauty, I can say this is more ductile failure, because under reinforced failures are more ductile failures, I can say. Maybe I can say clearly here. Let me erase ink. Under reinforced section failures are more ductile failures. But if you take balanced failure, even concrete is failing na. So even in balanced failure, concrete fails suddenly. So even balanced failure, concrete is failing na. When concrete is failing, it is not good. When concrete is failing, it is a sudden failure. It is a sudden failure. Let the concrete should not fail first. Let the steel should fail first. That is the design philosophy. Generally, we will use either in working stress method, or also in limit state method, or also in ultimate load method. In any method, generally in RCC, let the reinforcing steel, if there is a failure, it's happening, let the reinforcing steel fail first rather than the concrete. That is the design philosophy that we will try to apply. Is that okay? Is that okay? So in under reinforced section, I can say steel fail first than concrete. So ensuring a ductile failure. So it is a sudden failure, na. So this type of failure of balanced failure is also a brittle failure. So balanced type of design also I should not do. Let us suppose if I do the design by a balanced section, if I got the steel area as 1000 mm by balanced section, balanced design, in such case I need to provide steel less than 1000, maybe by 900 mm square, something like that I need to provide. In such case it will become under reinforced section, right? So in such case steel will fail first, concrete will fail second, which will ensure you ductile failure. So can I move to the next type of section, brother? Can I move to next type of section? Before I move to the next type of section, I just want to show here with the help of a thing. So I hope at the time of I hope you can see at the time of limiting depth of neutral axis for XU max, where balanced failure can happen. This is the depth of the neutral axis. If the neutral axis depth is here by this time, then I can say balanced failure is happening. By the time of balanced failure, strain in steel is this much, strain in concrete is point not 35. Here, when the depth of neutral axis is XU, when XU is less than XU max, I am calling that type of section is called as under reinforced section. How I can say that one, sir? When XU is less than XU max. So here when XU is less than XU max, in such case it is under reinforced section. In under reinforced section, which one we should fail? Steel should fail first, but concrete should not fail. So when steel is failing, steel should reach its permissible stress. As concrete is not failing, the strains in concrete should be less than the permissible strains. What is the permissible strain in concrete at a limiting stage? It is 0.035. As the concrete is not failing, the strain in concrete at the time of at the time of under reinforced failure, this value should be less than 0.035. So from here to here, if I draw a line here directly in this way, maybe with the help of definitely another color, maybe with the help of this red color, if I show clearly in this way, right? I hope clearly this is the point where this neutral axis is lying, right? This depth of neutral axis is XU. So clearly from observation also, right? From observation also, definitely you can understand XU. When XU is less than XU max, it is an under reinforced section. In such cases, steel should fail first. So when steel is failing first, that means the steel is reaching its permissible stresses and strains, whereas concrete is not reaching its permissible stresses and strains at the time of under reinforced failure. That is the direct conclusion you can write. Some people will also ask us, sir, what is the moment of resistance in this particular case? How you can write the moment of resistance? As xu is less than xu max, here I need to use xu only. So every time for moment of resistance I need to use compression force into lever or tension force into lever. Compression force is 0.36 fck b into, here I need to use xu only. Here xu is different na, so xu and xu max are different, so xu is xu, so this is compression force into lever arm. What is that lever arm? Maybe I can write d minus 0.42 xu. This is how I can work out moment of resistance with respect to compression force. If you people are interested to work out moment of resistance with respect to tension, equation 1 is with respect to compression force. With respect to second equation means with respect to T force, tension force. If you want to write moment of resistance with respect to tension force, I can write it as 0.87 Fy AST into d minus 0.4 to xu. So the difference between your previous balanced section and this section is, in balanced section, this value of xu is clearly taken as xu max. But here the value of xu is less than xu max. So here I need to use xu, not xu max. Please understand that. Here I need to use xu. Is that okay? Is that okay, Ramduchar? Last and final one. Last and final one is over reinforced section. After I teach you that one directly, we are ready to work out the problems. Is that okay? Right? Is that okay? Right. I just want to give that over reinforced section. Is that, I hope you are able to see this over reinforced section. So over reinforced section, in this one you can understand what is the physical understanding. Reinforcement is over. Reinforcement is maximum than the required amount of steel, just like for balanced failure. When compared to balanced failure, here the steel quantity will be higher in value. So I can say more reinforcement is there than balanced section. As more here, as steel quantity here, quantity or area of steel is increased than balanced section. So concrete quantity is obviously, concrete area has got decreased indirectly. As concrete area has got decreased, now you people tell me from common sense, in a team there are two different natures of members are there. Two different nature of members. One nature of members are higher in value, other nature of members are in lesser in value. In such case, the lesser number of group members, uh, their domination is less, they will fail first, right? So in such case, here as the concrete area is reduced, right? So as the concrete area has got reduced here, which one will fail first? So here failure is in concrete, as concrete quantity is less, as concrete area is less than balanced failure, right? So concrete will reach their permissible stresses prior to steel, right? Concrete will reach their permissible stresses and strains prior to steel. Let us suppose if this is if this let us suppose let us suppose this is xu max, where they corresponding to balanced failure. Let us suppose here concrete is reaching its permissible stresses, but steel is not reaching its permissible stresses. The strain in steel is less than epsilon st. So here it is less, here it is high. If I draw maybe a line, definitely from here to here, clearly you are able to understand what is the relationship between xu and xu max here. So here xu is more because steel area is more na. So as steel area is more here, generally here if I keep more steel here, then definitely XU value, that means this XU depth will get increased. Because of more steel here, XU value will get increased than XU max. So here in this particular case, XU is greater than XU max. And as the concrete is failing, a concrete failure is always a danger in nature. Concrete fails suddenly, so it is danger one. So don't design any section as if it is an over reinforced section. If you design any beam element as a over reinforced section, its moment of resistance is less, one thing I can say. And I can say forget about moment of resistance, its failure is sudden. Its failure is sudden. Reinforcement is more than balanced section. Concrete fails suddenly, which is a danger one, and XU is greater than XU max. So what the code of practice says, IS 456 says, don't design any IS 456 2000 advocates not to design any flexural element as if it is a over reinforced section. Let us suppose if for old structures, if you found any of the old structures as over reinforced section, its moment of resistance should be reduced to its moment of resistance in case an existing beam found to be over reinforced. Let us suppose if any beam was found to be over reinforced, in such case reduce its load carrying capacity or moment carrying capacity to that of balanced section. As per IS 456 2000, no beam section, no flexural element must and should be designed as a over reinforced section. ORS is not a drink. ORS is over reinforced section. 1 second, I will repeat. Over reinforced section. Sir, repeat. XU is less than XU max. Okay. Ramdut Shah says, Ramdut Shah is asking, sir, XU is less than XU max. Here it is not XU is less than XU max, dear. Here XU is greater than XU max, dear brother. Dear brother Ramdut Shah, here you tell me here which one is failing first? Concrete is failing. As concrete is failing, the compression zone, the permissible stresses in concrete will reach to the stresses and strains in concrete will reach its permissible stresses. Steel is not failing. When steel is not failing, the permissible strains in steel, the steel strain is less than permissible strain, so it is less than epsilon st. I hope you know epsilon st. The strain in steel is less than 0.002 plus 0.87 fi by es. When it reached to this strain, I can say the steel has got failed, but the strain in steel is less than this much, means the steel is not failing. So I can say this much is epsilon st. For example, when I go for this much, which is less than epsilon st. So if I go from here to here, if I draw a line clearly, maybe with respect to another line, if I draw a line here from here to here, you can clearly understand this is the neutral axis, right? So when this is the neutral axis, this is XU. So from this one observation also you can understand XU is greater than XU max, not less than XU max. So please understand XU, some people will say like, sir, can you write the answer? XU is equal to XU max. In such case it is balanced. When XU is less than XU max, and XU is less than XU max, in such case I can say it as I can clearly say that one as under reinforced. When XU is greater than XU max, it is over reinforced. It is over reinforced. Okay, it is over reinforced. Is that okay, dear Ramdut Shah? Right? Is that okay, dear Ramdut Shah? Right? Is it okay? Right. Okay. I hope you understood how you can decide, how you can judge a type of section. You can judge a type of flexural section of RCC by comparing XU and XU max, right? By comparing XU and XU max, you can come to a conclusion whether it is balanced section or under reinforced section or over reinforced section. Out of these three type of sections, I always need to design a section as an under reinforced section. If you design as a balanced section, after you find out steel, keep the value of steel area lesser than the steel area required in case of balanced section. In such case, it will be converted as under reinforced section only. Okay, right. Right. So I hope you are able to see this point. In case if any in case of design, in case of design, over reinforced section ORS should be strictly prohibited as per IS 456. Let us suppose before 2000 there may be some of the constructions may happen with over reinforced sections. If you want to find out moment of resistance for those beams which are coming as over reinforced section, to find out moment of resistance for over reinforced section, the code says is reduce its load carrying capacity or moment carrying capacity to that of balanced section. So for over reinforced section also, moment of resistance is limiting moment of resistance, MU limit. How you can work out this MU limit, brother? By considering XU as XU max. If you consider XU as XU max, definitely how you can write that moment of resistance, it is 0.36 FCK B into, instead of XU, I need to write XU max here because I need to reduce the moment carrying capacity as XU is greater than XU max, but the code says limit the moment of resistance or limit the or reduce the load carrying capacity by limiting the value of XU as XU max. So I can write XU max into, this is compression force, into lever arm. Lever arm is D minus 0.42 XU, but instead of XU use XU max. So what is the clear thing that I can say? Clear thing that I can say is for balanced section and ORS, over reinforced section, for balanced section and over reinforced section, use XU max in moment of resistance. For under reinforced section, maybe I can say for under reinforced section, maybe for under reinforced section, what I need to use for under reinforced section, use XU while I need to work out moment of resistance. This is the final conclusion that we can draw, isn't it or not? Sir, for working stress method, will you explain in later classes? Dear, I try to, yes, the working stress method that will takes place in, let me complete all the topics with respect to limit state, and after that one is over, in next month I may tackle about this working stress method. Okay, right. So the emphasis, especially in GATE, they won't ask you any question on working stress concepts. Only in ESE, the concepts of working stress methods were there because water tanks were there. In water tanks, the concept of working stress method is required. Okay, right. So maybe I just want to give right. Some people will say like, sir, these are the limiting moment of resistance. Before I just go to the problems, I just want to give the direct formula for limiting or balanced moment of resistance. What is limiting moment of resistance for FE 250 grade? This is for FE 250 for mild steel. If you just keep XU max as 0.53 times of D, here XU max as 0.53 times of D, then you will get MU limiting moment of resistance for Fe250 is 0.148 FCK BD square, and XU max I can write as 0.53 times of D. These are standard values for IS 456 test block. Please understand, these are standard values for IS 456 test block, not for the new stress block that may be asked in GATE examination. Okay, so I want MU limit for limiting moment of resistance for Fe415 stress block. For Fe415 stress block, XU max is 0.48 times of D. In XU max here, if you keep 0.48 times of D in the above formula, here in this above formula, if you substitute XU max, then definitely for Fe415 you will get this limiting moment of resistance at 0.138 FCK BD square. This I just want to convey applicable only to IS456 2000 stress block and strain block parameters. If anything has got changed, these values will also get changed. Please understand that. So let us suppose if it is HOSD FE 500 grade of steel is used, HOSD, but for which XU max by D is 0. I had already derived this one. In such case, limiting moment of resistance is 0.133 FCK BD square, right? So is that okay? So from this, all these three, you can understand, you can come down to a conclusion like for Fe 250 grade, the limiting moment of resistance is high. But why we are not using this mild steel as a main steel or as tension steel? Why we are not using mild steel? The major problem with respect to mild steel is bond problem. Because of bond problem only, we are not using mild steel. To avoid bond problem, there should be sufficient grip should be there. The sufficient grip should be coming into picture because of rips, or I can say because of threads on HYSD bars. So that's the reason why I can say for beams the best the best steel is for beams is Fe415 steel, whereas for columns the best steel is Fe500 steel. Okay, but let me directly move to problems, bros. Okay, 1 second. So can you see this problem? Can you see this problem? Dear Ramdut Shah, right? I will move from very basics levels to the level will get keep on getting increased. So can you go through this problem, bro? Right? Okay, right? Ramdut Shah, bro, or other persons who are on the online, like Vasan Sai, Koppala Kaushik, Ramdut Shah, right? Shebin Sailuddin. Yeah. Can you go through this problem? Can you work out? Yes. A singly reinforced rectangular section of 200 millimeter wide by 400 millimeter effective depth, reinforced with 4 bars of 20 millimeter diameter mild steel bars. The concrete used is M15. The ultimate moment of resistance of the beam. They are expecting ultimate moment of resistance. So you can use, they are expecting moment of resistance, ultimate, that they are expecting moment of resistance because it is in limit state. Now that's the reason why they are mentioning that moment of resistance is nothing but ultimate moment of resistance. So I need to work out moment of resistance. How you can work out moment of resistance? Generally compression force into lever arm or tension force into lever arm. Anything you can use. But the thing is, in lever arms or in compression forces, shall I use XU or XU max? That is the only thing that you need to judge. So that shall I need to use XU or XU max? That depends on judging the type of section. Can I judge the type of section, brother? To judge the type of section, first of all, I need to work out XU max. Step 1. Work out XU max. What is XU max answer for mild steel bars? I hope for mild steel bars we had already worked out XU max as per IS 456 2000. What is that XU max value, brother? XU max value is 0.53 times of D. So the what is the effective depth here? The effective depth is 400. So I can write 0.53 times of 400 millimeter. If I do this stuff, brother, what will be the answer? 212 millimeter. This is XU max. What is the step 2, bro? Maybe let me change the color. Yes. What is step 2, bro? Step 2, I need to find out actual depth of neutral axis. Finding actual depth of neutral axis. How to find out actual depth of neutral axis, brother? By equating compression force is equal to tension force. This is the one and only way to work out actual depth of neutral axis. How you can write this compression force for IS 456 2000 stress block, because no change in parameters, nothing was mentioned. Na? So I am free to use directly the formulas that was provided in IS 456 2000 as per limit state method, which is 0.36 FCK B into XU, which is equal to 0.87 Fy into AST. Is that okay? Now can you just substitute all this stuff? 0.36 FCK. What is the grade of concrete? M15. M15 is the grade of concrete, means FCK. The grade of concrete is FCK is 15. What is the width of the beam? The singly reinforced rectangular section of width 200 millimeter. The width is 200 millimeter. 200 millimeter into XU is equal to 0.87 into Fy. What is Fy? Yield strength of the steel. It is mild steel bars. When it is mild steel bars, the yield strength is 250 megapascal. Right, into area of steel. How much? What is the area of steel? Reinforced with 4 bars of 20 millimeter diameter. So what is the area of steel? So for number of bars into cross sectional area of single bar. So 4 into, I can write as pi by 4 into diameter of single bar 20 square. So I hope from this one definitely you are bound to work out the value of XU, isn't it or not? Can you work out the value of XU from this one? If you work out the value of XU, definitely you are bound to get it as 253.073 millimeter, right? This is XU, this is XU max. So what is the conclusion about the type of section, man? So conclusion about the type of section. Can I use the next slide, brother? Can I use the next slide? Yes. So moving using the next slide, brother. So in this next slide, maybe I can say step 3, judging the type of section. If you can see about the judge the type of section here, XU is greater than XU max. When XU is greater than XU max, the section is over reinforced section. When the section is over reinforced section, moment of resistance is definitely, it is equated to limiting moment of resistance. Limiting moment of resistance is the moment of resistance for over reinforced section I can use, and also for balanced section I can use, which is definitely, it is equal to limiting moment of resistance, which is compression force into lever arm. Compression force is 0.36 FCK B into XU max I can use, into lever arm D minus 0.42 XU max. If you substitute XU max in this XU max, if you substitute directly the value of XU max for mild steel, XU max is 0.53 times of D. If you substitute XU max as 0.53 times of D, directly you will get this answer as 0.148 FCK B into D square, brother. So directly substitute, or else directly you are free to use this limiting moment of resistance formula, because it is an over reinforced section. So it is 0.148, FCK is 15, breadth of the beam is 200, effective depth that was given in the problem is 400 square, isn't it or not? So in this case, definitely if you work out, you will end up with this everything you will end up with in Newton per millimeter. The answer is 71.2 into 10 to the power of 6, you will get as Newton millimeter. The answer is 71.2, I can write as kilonewton meter. So where you can see this 71.2 Newton kilonewton meter, brother. So 71.2. So the nearest answer is 72. So you can keep B for Boston is the correct option. Is that okay? Dear Ramdut bro, is that okay? Shall I move to the next problem? Right? Yes. So moving to the next problem, dear Ramjut bro. Right. Moving to the next problem. I hope you are able to see this problem. Right. So in your previous example, the cross section, the type of section that we had judged is a over reinforced section. So here also they are expecting moment of resistance only. Okay, ultimate moment of resistance only. To work out ultimate moment of resistance, first of all, you need to judge the type of section, right? Need to judge the type of section. Isn't it or not? How you can judge the type of section, brother? By comparing XU and XU max, isn't it or not, brother? So how you can compare XU and XU max, right? Can you work out that one? So yes, how here it is a mild steel bars, right? So maybe I can say step one, work out XU max. How you can work out XU max for mild steel bars? For mild steel bars, XU max is how much, brother? It is 0.53 times of D. The same problem, I mean the same above problem, but instead of 4 bars, okay, I can say if there are 3 bars are there, actually instead of replace it the same problem, but instead of 4 bars, when there are 4 bars, it is over reinforced section has came. But here when the number of bars are 3 bars, then they are expecting limiting moment of resistance. When the number of bars has got reduced, there is a chance like the section can get converted to I can say under reinforced section, right? So I can say maybe this is 0.43 times of D. Definitely it is 212 millimeter, no doubt. And coming to XU, how you can work out XU, brother? The value of XU can be worked out by writing compression force is equal to tension force. So how you can write compression force is equal to tension force? 0.36 FCK 15, 0.36 FCK B is 200 into XU. I need to work out. It's equal to tension for 0.87 F5. The grade of steel is mild steel bars na 250 into how many bars they are expecting mild steel bars when the in the reinforcing bar, and the reinforcing bars are 3 bars are there. So I can write 3 into pi by 4 into 20 square. When you do this one, definitely the value of XU is 189.8 millimeter. So if I use another color, maybe this value of XU is less than XU max. When the value of XU is less than XU max, this is an under reinforced section. I can write as URS, under reinforced section, right? When I do this under reinforced section, now can you work out limiting moment of resistance? Well, can you work out ultimate moment of resistance? The ultimate moment of resistance is MU, or we can call it as moment of resistance or ultimate moment of resistance. Why the terminology ultimate moment of resistance came into picture instead of moment of resistance? Because we are working out the moment of resistance at limiting stage or at ultimate stage. At that stage, the moment of resistance is nothing but ultimate moment of resistance, right? So I can say ultimate moment of resistance, MOR, which we can write as compression force into lever arm, right? What is that compression force? Here XU is less than XU max, na? So what is the conclusion that can draw? By the time I am using MU, use XU only in this formula. Compression force into lever arm. Compression force is 0.36 FCK into B into XU. This is as usual compression force into lever arm. D minus 0.42 XU. Only I can use XU max for balanced section, and for over reinforced section only I can use this limiting moment of resistance. So only I can use XU max. Okay, right. This is 0.36 FCK. What is that FCK? It is 15. B it is 200 into XU. What is the value of XU? What is 189.8 into effective depth? It is 400 minus 0.42 into XU. XU value is 189.8. If you work out, definitely maybe if I change the color, okay, 1 second, if I change the color, definitely this value will be 65.6 into 10 to the power of 6 Newton millimeter. But they are expecting this answer, moment of resistance in kilonewton meter. If they are expecting this answer, ultimate moment of resistance in kilonewton meter, right? So if it is 65.6 kilonewton meter, so it is 65.6 kilonewton meter, which is nearly it is equal to 6. Pick directly option D. D for Detroit is the correct option. Like that we can directly pick. The Ramducha, I need to consider only 3 bars, because if you see the ultimate moment of resistance, if the reinforcement is 3 bars of 20 millimeter dia. Can you see here? They are expecting moment of resistance by the time when the bars are 3 bars only. By the time when I keep 3 bars, by that time what is the depth of load legs I need to work out? What is the moment of resistance I need to work out? Because they are expecting the moment of resistance when the number of bars are 3. It is only English only, right? So This is this question number 6. Both these questions are linked statement questions, brothers. So in the first, the previous question and this question are one and same. In previous question, there are 4 bars are there, but in this question there are 3 bars are there. That is the only difference. Because of the difference, the previous section is a over reinforced section. This in this problem, the section is an under reinforced section. So because of which the moment of resistance formula and its values all will get changed. Isn't it or not? Ramdutsha. Is that okay? Right. Okay. Right. I hope Ramdutsha understood. Maybe. So let me go to another problem. So can you see this problem, brother? A reinforced concrete beam. Yes. Right. So reinforced concrete beam of size 250 millimeter wide and 400 millimeter deep overall depth. This is overall depth, means capital D is 400 millimeter. Okay, is supported over a span of, it is supported a beam with, okay, let me take a beam, is supporting over a span of how much span it is supporting? It is supporting 4.5 meter. Maybe let me show these two reactions. Okay, simple supported, and the span is how much, brother? The span is 4.5 meter. It is showing in that way. Okay, it is subjected to 2 point loads P of equal magnitude placed at middle third points. So 2 point, so middle thirds. So middle thirds means 2 point loads are placed at middle thirds. So middle thirds means if the total span is 4.5, so every point load from this end should be at a distance of 4.5 by 4.5 meter by 3. From this end, this point load is at a distance of 4.5 by 3 meter. That is what is middle third. The loads are applied at middle thirds. Okay, right. The two loads are gradually applied. These loads are gradually applied. So you can think it is a laboratory testing, because in laboratory testing only the loads can be applied gradually. So it is a laboratory testing. Physically you can understand in that way, because only in laboratory testing only you can apply the loads gradually, right? Isn't it or not? Right. Okay. Beam is reinforced with two HYSD bars of Fe415 grade of 16 diameter bars placed at an effective cover of 40 millimeter. So if capital D is 400 millimeter, effective depth is 400 millimeter minus effective cover. Effective cover is how much, brother? The effective cover is 40, maybe 40. So in such case, it is 360 millimeter. Okay. The characteristic compressive strength and bending tensile strength of concrete. So they are saying FCK is 20 megapascal, and the bending tensile strength of concrete, the permissible, the bending tensile strength of the concrete is 2 megapascal. They are saying that F limiting bending tensile strength of concrete, bending tensile strength, which is 2 megapascal. Okay, they had given in this way. They are saying ignoring, there is a word called ignoring the presence of tension reinforcement. When there is no tension reinforcement is there, you think like there is no reinforcement in this there. When there is no reinforcement in this case, this is a plain cement concrete. When it is a plain cement concrete, it is a single material one. When it is single material one, right, they are expecting find the load P in kilonewton when the first flexural crack will develop. So when there it is the single material one, by that time you can understand, when it is a single material one, we are free to use we are free to use flexure formula. Flexure formula I am free to use to find out the maximum bending moment to be resisted. Use flexure formula to find moment of resistance. So the moment of resistance right now I can work out from flexor formula. So what is the flexor formula? How you can work out that flexor formula, brother? Sir, why you subtracted? Ramdut says like, sir, why you subtracted 400 minus 40? Dear brother, capital D is overall depth of the section. This is capital D. Small d, what do you mean by small d, brother? Maybe dear Ramdut, small d is effective depth. So effective depth, how you can say about effective depth, dear Ramdut, brother? One second, let me show you here. Effective depth. In your previous class, I had shown this one, but anyway, effective depth is overall depth minus effective cover, right? What is overall depth that is given in the problem? 400. See, small d is effective depth, capital D is overall depth. Okay, right. Now if I want to show with the help of the sketch, when I ignore the reinforcement, this is how the cross section details. This is 250 millimeter and this depth is overall depth, because I had neglected the reinforcement. When I neglect the reinforcement, there is no reinforcement, means the overall depth only I need to consider. D is 400 millimeter. I can say no reinforcement. If there is reinforcement, if I show with reinforcement, maybe here, if I show on the right hand side, if I had shown reinforcement, maybe here, right? Now if I had shown reinforcement, this depth is nothing but effective depth, small d, which is capital D minus small d is equal to capital D, and this is effective cover. How you can define effective cover? Effective cover is the centroid, it is the centroid distance of the tension steel to the nearest tension fiber. That distance is nothing but effective cover. This is effective cover, and it is given clearly as 40 millimeter. Is that okay, dear Ramdut Shah? Right? So maybe I hope you had seen this one. Right. Now I hope after you do this one, if you please excuse me, I just want to erase. I just want to erase this stuff clearly. Okay. So you understood, like we are free to use this flexor formula. So we are, when we are free to use the flexor formula, what this flexor formula will teach you. Before you use this flexor formula, I just want to convey in the flexor formula. If I write m by I is equal to f by y, where f stands for limiting or maximum bending stress. By the time to get maximum bending stress, the value of m needs to be applied, should be the maximum bending moment. So what is the maximum bending moment that has got developed? This is how the bending moment diagram is, this has got developed. This is p, these reactions are p, this reaction will also be p, and if this is a, I can write this as a, this is also a, this distance is a. So this maximum bending moment, definitely this value of this maximum bending moment I can write as maybe this or this. Clearly I can write as p into a. Some people had a doubt like, sir, why you are applying this flexor formula? This flexor formula can only be applied in pure bending zone. Is there any pure bending zone? Pure bending is possible. I hope clearly for this zone from here to here, it is pure bending. As in this zone, pure bending is existing. That's the reason why I am free to apply this flexor formula within this zone. Maybe within this zone, I am free to apply the flexor formula, right? Within this zone. Is that okay? So what is that flexor formula and how you can do that one? Now coming to that, right? So coming to that, maybe I can say like, sir, f is equal to m by I is equal to f by y. If I write f is equal to, get f is equal to f max, which is equal to m by z. So I can write what is that moment is P into A. So how you can write that P into A, brother? So this P, if I want to get that P, I can write that P as these are the p's. If there is a point load is subjected to 2 point loads p of equal magnitude. If it is subjected to load p, so p is there. And a is how much, brother? A is in 4.5 by 3. For a is 4.5 by 3 means 1.5 meter. So a is 1.5 meter means here I can say clearly a is definitely I can write as 1.5 meter. How I can write 1.5 meter? I need to write meter in terms of millimeter. So I can write into 1000, right? Divided by Z. What is the Z? What is the section modulus of this section? The width of this section is 250 and the depth of the section is 400. So what is this? What is this Z? Section modulus for this section? Section modulus for this rectangular section is BD square by 6. What is that value of B? B is 250. D is how much, brother? Effect the overall depth is 400. BD square by 6. I can write in this way. This is m by z, which is f. And what is the limiting value of bending stress? And it is equal to, if you take, this is how the bending stress is possible. What is the maximum bending tensile stress that is given in the problem? So if you see, the bending tensile strength of concrete is taken as 2 megapascal. So this maximum bending strength or bending tensile strength, this must and should be equated to 2. So from this one, definitely you are bound to get, right? If you write the value of this P will be 8.8 into 10 cube Newton. If I write this value of P in terms of, because P I will get definitely in terms of newtons, because the stress is in Newton per millimeter square na. So the value of P you will get in Newton. When I work out that in kilonewton, the value of this P will be 8.8 kilonewton. 8.8 kilonewton. So when I remove this reinforcement, it is just like a plain cement concrete. And moreover, when it is plain cement concrete, moreover there is a pure bending zone is existing. Yes, pure bending zone is existing. I am free to apply the flexure formula. The flexure formula can only be applied in pure bending zone, and the flexure formula can only be applied to the materials in which only single material is there, not for composite materials. If it is a composite material, I need to apply Euler-Bernoulli's theorem, just like for RCC how I are working out that stresses and all the stuff like that I need to work out, right? But this is a plain cement concrete when I neglect the reinforcement. Is that okay? So the final answer is P is 8.8 kilonewton. Is that okay? Right? So please excuse me for today. I am just stopping the session as the time is already more than one. So 2 hours only is the time. So we will work out the remaining problems. There are so many problems are there. You will see all these problems in the coming session. So before I end up the session, I just want to convey, if you are a serious aspirant of GATE and ESE, then I can definitely recommend you to take the paid subscription. The paid subscription for 12 months course is 27,225. For 24 months course, for 24 months courses, it is paid course is 39,600. I can say, to get 10% discount, after 10%, to get 10% discount, you are bound to use this code with 10 in an Unacademy learning app, especially in plus courses, in Unacademy plus, in Unacademy plus. Okay, right? So use this, don't forget to use this code VT10. When you use this code VT10, definitely it will connect between you and me, and I will take care of your entire preparation, brother, if you are able to use this code VT10 to purchase this course. Okay, right? So, and I just want to convey, we already started these 3 new batches. Take use of these 3 new batches of this Let's Crack GATE ESE and Civil YouTube channel also. And one more thing, like every day my class is happening by 11 a.m. in this Let's Crack GATE and ESE Civil channel. Please take use of that. And finally, I just want to convey, you are all getting these lectures for free of cost. Please share these videos to your friends so that they will also get benefited. Even though if they are not able to purchase the course, at least they can use some of the free lectures, like this 20 percentage to syllabus, 30 percentage syllabus in depth will be covered, right? So why don't you convey the same thing to your friend, so that they will come down to this platform and they will also get benefited, right? So please say the same thing to your friends and ask them to come down to our platform. Please subscribe to this Let's Crack Gate and ESE channel, and don't forget to press the bell icon. And if you press the bell icon, the future coming videos will also be notified to you, so that you will not miss even a single lecture also. And please raise a thumbs up, please raise a thumbs up, and please share this video. Please subscribe to our videos. And I already started a Telegram group also, and the name of the Telegram channel is Unacademy underscore civil engineer Tilak. And if you come down to this Telegram group, the few notifications of the lectures and some notes, or maybe I can say, if you had any doubts, you can post your doubts here, so that we can clarify your doubts for free of cost. You can come down by using this link which is shown below. If you don't, if the link is not directly accessible, you can type the same thing, Unacademy underscore civil engineer, civil underscore engineer underscore Tilak. You can type this name in the Google, in the web, and it will directly redirect to my Telegram group. So come and join my Telegram group. Thank you. End of the session. Okay, thank you very much.